Today what we're going to be doing is taking the last 3 days, so our quadratic functions in vertex form, intercept form, and in standard form, and apply them to real-life situations. And when we do that, we're going to be looking at some word problems, and there's going to be some key words to look out for, and that's going to tell us what we're looking for mathematically. So if we're trying to find the maximum or minimum height or value, we're looking for the vertex of your quadratic function, and more specifically, the y value of the vertex. That's going to tell us the minimum or maximum value of our word problem. And we know how we can get the vertex in vertex form, intercept form, and standard form. Then landing on the ground, what we're looking for then is we're looking for the x-intercepts. In other words, y is equal to 0. And we're going to get into that part, y equals 0, later on. But if we are given a function in intercept form, we can then find when this object or whatever it is lands on the ground by getting those x-intercepts. Horizontal distance, we're looking in the x direction, x values. And then the vertical distance, that's going to be y values. And then finally, your starting point is going to be your y-intercept, or when x is equal to 0. Yeah, and in standard form, it's very easy to find the y-intercept because it's your c value, but in any other function, we can just plug in 0 for x to find that y-intercept. So if we're looking at example 1 here, it says the path of a place kick football can be modeled by the function y equals, and then we have that, where x is a horizontal distance in yards and y is a corresponding height in yards. So how far is a football kicked? So again, we're going to be looking at horizontal distances here. So we know from this part right here that one of our intercepts is 50, 0. And we know from this one right here, yeah, there's no parentheses and it's not x minus or x plus anything, so that means the intercept is actually 0, 0. So again, for the horizontal distance, how far is it from 0 to 50? Well, that's 50 yards. Now, what is the maximum height of the football? So we need to find our halfway point between our x-intercepts. Well, 50 plus 0 over 2 is 25. So the max occurs 25 yards out horizontally, but what is that y value? So we're going to plug in 25 for both x values, and then the y value, so whoops, it's negative 0.025. Negative 0.025 times 25 times 25 minus 50, and we get 15.625 yards. So that would be our maximum height. Now, example 2, we are given a function in intercept form. So let's graph it. Our intercepts are negative 2, 0, and 5, 0. So in this problem, we're jumping off a diving board, and our height goes in this function. This function tells us the path that we are jumping. So the x-coordinate of the vertex, -2 plus 5 divided by 2, that's going to be 1.5. And then, that's also our axis of symmetry. And the work for the y-coordinate, -0.5 times 1.5 plus 2 times 1.5 minus 5. So if we type that into the calculator, that is going to give us the y value of 6.125. So that means our vertex is 1.5 comma 6.125, which is a maximum value at 6.125. So now we can graph this. We're going to go 1/2 over and then up 6.125, 1, 2, 3, 4, 5, 6, and a little bit more. So that is our domain, or that is our graph. The domain, since this is a quadratic, we would say -infinity comma infinity because that's what we know, but it says in context. So in context, we are only looking at the positive x-axis because it says t is time and we can't have negative time. So we have 0, we'll bracket, because that's when time starts. And then when does the problem end? The problem ends when we hit the water. So right here at 5, 0, that is when the problem ends. So that means 5 is the upper limit for the domain. Then the range, the range is the problem is done once we hit the water. So 0 is the smallest y value here. And the largest y value is a 6.125. So that would be our range in context. How high above the water do you jump? So if our water is at 0, then 6.125, the y-coordinate of our vertex, is our maximum height. How high did we get? And we are in yards. Those are units. What do the x-intercepts mean in the context of the problem? Well, that's when our height is 0. So that's when we are on the water. How tall is the diving board? Well, the diving board would be our initial height, because if you think about it in this problem, if we're sitting on a diving board and jumping up and then landing in the water, our initial height when t is 0 would be our y-intercept. So we're going to plug in 0 for this function. So -0.5 times 0 plus 2 times 0 minus 5. So the y-intercept is 5. So that's where, that's how high the diving board is, 5 feet. Now you might have been able to go by the picture, but the math is way more accurate than the picture. In example 3, it says the Tacoma Narrows Bridge in Washington has 2 towers that each rise 307 feet above the roadway and are connected by a suspension cable as shown. Each cable can be modeled by the function, that thing, where x and y are measured in feet. What are the maximum and minimum distance between the suspension cables and the roadway? So this is our vertex right here. Oops. Yeah, the x value is 1,400 and the y value is 27. We get this from vertex form right here. So we're trying to figure out the maximum and minimum distance from these cables here. Well, the maximum is going to be 307 feet at the beginning and end of the bridge. So the max would be 307 feet. The minimum, though, occurs right here. Well, the y value right there is 27 feet, so the minimum would be 27 feet. Then how long is the bridge? Well, horizontal distance, we know the vertex is halfway there, and halfway there is 1,400, so then we multiply that by 2 to get 2,800 feet. So we're able to use vertex form to get these answers. Right, then last problem, it says using the graph at the right, it shows the height h in feet of a small rocket t seconds after launch. The path of the rocket is given by this equation. How long is the rocket in the air? So if we look at the graph, the path the rocket goes up and then it comes down, and the horizontal axis is time. So right here, we look at that and we say, oh, we have an x-intercept at 0 and an x-intercept at 8. So the distance between that is 8. So we were in the air for 8 seconds. What is the greatest height that the rocket reaches and how long does it take to get there? So we look for the vertex, which is right here. And we get there at 4 seconds. And you might be able to tell from the graph that it's like 260. But we want to be able to get the exact answer. So negative 16 times 4 times 4 minus 8. And we get negative 256. So that is the maximum height. So max height, 256 feet. And it happens in 4 seconds. C, about how high is the rocket after 1 second? So we're going to plug in 1 for t. So I'm just going to go back and change my 4s to 1. And we get 112 feet. And we got that by plugging in 1 for t. After 6 seconds, is the rocket going up or going down? Well, we can look at the graph and see that the rocket is at the max at 4 seconds, and then as it comes down, it's right, 6 seconds is right there, so we are going down. This one requires a little bit of thinking. Do you think the rocket is traveling faster from 0 to 1 second or from 3 to 4 seconds? Well, if we erase all this junk here, let's compare the slopes of those, because that might give us a good idea of what's going on, because slope is your rate of change. So from 0 to 1, we went up by a little over 100. And then from 3 to 4, look at, we're only going up by a little bit. Our overall height didn't change. So it's probably going faster from 0 to 1 second. Whoops. Because the slope is greater than there. The slope in that interval is larger than the slope from 3 to 4. Or you could say that the y values didn't increase as much. Increased more from 0 to 1 than 3 to 4 in the x direction. So we're looking at the x values, not the y. All right, domain. Well, domain is going to be 0 to 8 because the rocket started at 0, 0, 0, and then it went up, and then it came back down 8 seconds later. The range, okay, again, the rocket started on the ground, and its maximum height was 256 feet. So we say 256, and then close the bracket. So this is why it was super important for you to be able to identify all these characteristics from the quadratic equations that we have, because then we're going to take those values and interpret them in the story problems. So that's why we spent a lot of time looking at just quadratic functions and being able to graph them in all the forms. So thanks for watching. Make sure to like the video and subscribe.